If two events are independent of one another, which means that if one event happens, it doesn't impact the chances of another event. So if they're independent, then you can find out the probability of both of them happening by multiplying their individual probabilities. The probability of A happening, event A, times the probability of event B. That's only if they're independent though. So the probability I wear a blue shirt tomorrow and the probability that a meteor strikes the Earth, those are not likely to be impacting one another, right? If I choose my blue shirt, it doesn't increase the chances that that meteor is going to impact the Earth. So probability that I pick a blue shirt, 0.5. Probability that a meteor strikes tomorrow, everyone knows it's going to happen, so it's 0.9. No, I'm just kidding. You multiply those two probabilities, find out the chances of both of them happening. So in this example, if you've had a chance to read through it, the probability that the first one is defective is 0.001, and the problem assures us that if one of them is defective, then the other that doesn't impact the chances of the other ones being defective. You can make an argument that these should be dependent if they come from the same factory, but if they're two different brands, that probably assures us that they're both independent of one another. So we can find the probability that both of them are defective, that both of them have that criteria by multiplying them. The probability that the first brand's defective times the probability that the second brand's defective, that's the chance of both of those being defective. So they can be pretty sure when they're testing these outlets or doing whatever they're doing to test. I don't need to write out those zeros, right? There's a lot. So that's a probability. You want to multiply that by 100 if you want to view it as a percentage. That's a 0.0001% chance that both of those are defective and that you're missing something. So an AI detection tool says the first submission was 85% chance that it was AI, 90% chance that it was AI, 95% chance that it was AI. So what's the probability that none of these three submissions are AI? So to make that calculation, we want to find out the probability that this first submission was AI. If it's 85% chance that it was AI, so the probability that it was not AI is 0.15. And then they told us to assume they're independent, so to find out the probability that all three of them are not AI is found by multiplying the probability that each is not AI generated. So what's the probability that none of these were written AI? Well, if they're independent, we could find the intersection of those three events by multiplying each probability. So the first one had a 15% chance of not being AI, 90% chance that it was AI, so that means there's a 10% chance that the second one is not AI. And the same thing for here. And if you multiply those three together, that's a pretty low chance, right? 0.00075. So if you want that as a percentage, 0.075% chance that this student didn't use AI. That's really low. At this point, the instructor's right to question it, right? If we change the question, say, what's the probability that the first two, that both of the first two were not AI? It's 0.15 times 0.1. So that's still a pretty low chance. It's a 1.5% chance that the first two were not AI if we don't even consider this last one. Okay, friends are trying to play a game of soccer either Friday, Saturday, or Sunday. So the weather forecast estimates the probability of rain for Friday to be 0.3, Saturday to be 0.4, and Sunday to be 0.5, assuming that each day the probability is independent, which, really that's questionable in real life. If it rains one day, maybe that means it's less likely to rain the next day. But we're going to assume that they're independent. What's the probability that all 3 days will rain? Well, if we're assuming independence, then we just need to multiply the probability of rain on each day. So the first day on Friday, it's 0.3, Saturday 0.4, Sunday 0.5. So the probability that it will rain on all 3 days is pretty low, 6% chance, 0.06. So that means they should expect one day not to have rain.